Hello everyone. In this lectures I am going to start a new topics. The topic name is fatigue analysis. This is a very important topics for welded joint. So, in this topics I will cover the basics of fatigue analysis to very advanced level of fatigue analysis related topics, which is generally used in the field of welding joints. So, in today's lecture I will discuss about basics of fatigue analysis. The content of today's lecture is, here I will discuss about in introduction. In introduction I will discuss what is fatigue life, then I will discuss about the differences between static loading and fatigue loading related failure. Then I will discuss about characterizing of fluctuating types of stresses. I will also discuss about how to determine the fatigue life of a structure. That experimental procedure in details I will discuss. I will also discuss about what are the effect of welding on fatigue life. Then at the end I will discuss how to calculate the fatigue life, or you can say how to calculate the endurance limit by some approximate method. Apart from this, actually in this lectures I will cover the how the fatigue related fracture is taken place, how it's look like, that related things also I will discuss in this lecture. So, first of all we should know what is fatigue. So, generally in fatigue the loading type is fluctuating types of loading. What is fluctuating type loading? I will discuss in subsequent slides in detail. In case of fatigue loading or fluctuating types of loading, the component may fail even though the applied stress range is within the elastic limit. That means, the applied stress range is within elastic limit, then also the component can fail. What I am telling, understand? So, there is no progressive, you can say there is no gross plastic deformation of the material also here is taken place, then also a fatigue failure can take place. Another important point we should know, generally it is observed that the magnitude of stress which causing the fatigue failure, which generally decreases as the number of cycle increases. That means, if a structure is subjected to this fluctuating types of loading, then what happens, if the number of these fluctuating types of loading cycle increases, then the fatigue failure generally taken place with lower stress level. What I am telling, understand? That is why here I have written, it is found that the magnitude of stress causing fatigue failure decreases as the number of cycle increases. Now, these phenomena of decreased resistance of the material due to this fluctuating types of loading or fluctuating types of stresses is called fatigue. So, you got the idea what is fatigue means. Due to this repeated loading, what happens? The load bearing capacity generally you can say decreased of that material. Then this phenomena is known as generally fatigue. Now, fatigue and fracture behavior is a very important topics in case of welded joint. That is why what happens, these types of fatigue related topics is very much important, which is widely considered in the field of design of bridge, pressure vessel, crane and other engineering component which are subjected to fluctuating types of loading. You know, a bridge which is subjected to some different types of you see loading, like what happens over the bridge there can go motorcycle, then buses, taxis and some private car. So, lorry, these types of things can go. So, what happens due to these things, what happens, this bridges is subjected to what, some fluctuating types of loading. Due to these things what happens, as these bridges, then pressure vessels, even some ship structure which is generally running in sea or ocean, where it is subjected to some wave types of loading. This wave types of loading is a type of fluctuating types of loading. So, due to this also what happens, there is occur some fatigue types of failure in sheaf structure. So, that is why what happens, this fatigue and fracture behavior of welded joint is become a very important consideration in these types of structure like bridge structure, shipbuilding structure and some other structure which is subjected to these types of fluctuating types of loading. It is observed that 80 to 90% welded related structure is failed due to fatigue failure. Now, another terms which is a very important term, that is actually called fatigue life. What is fatigue life? This fatigue life is defined as the number of stress cycle that a standard specimen can complete during the test before the appearance of first fatigue crack. This you should keep it in mind. That means, before the appearance of first fatigue crack, a standard specimen, how many number of this fluctuating cycle it can sustain. What is a fluctuating cycle? Little bit I am just showing, like what happens, fluctuating cycle means it can be sinusoidal types of load, or it can be some non-sinusoidal types of load also. So, a complete cycle means you see it is varying from, you can say 0 degree to 360 degree, you know very well. It has a 0, then you see it has a maximum value, then it has a minimum value like this. Okay. This types of loading is generally called fluctuating types of loading. Here generally this represent time and this represent, you see, stress amplitude. So, what happens, this fluctuating loading can have different categories also, that I will discuss in subsequent slide. First of all, we should know what is the difference between failure due to static loading and failure due to fatigue types or fluctuating types of loading. So, this is very much essential to know. First of all, we should know what is static types of loading. Static types of loading means what happens, it is a gradually applied loading. That means, here one thing you can say, in case of static types of loading, generally this load is applied, you can say slowly. That is why what happens here, inertia effect would not play a role, this you should keep it in mind. So, in case of static types of loading, inertia is not play a role, whereas in case of, then you should know what is dynamic loading. The dynamic loading refer to any loads that varies with time, such as you see vibration, shock, impact or cyclic types of loading. Now, in case of fatigue, generally it is a fatigue is a progressive damage and failure of the material due to repeated or you see fluctuating types of stress. This you should keep it in mind. So, you got the idea what is static types of loading, what is dynamic types of loading and what is fatigue types of loading. So, dynamic types of loading it depends on time, as well as fatigue types of loading also it depends on time. So, dynamic types of loading can be any types of load which is depends on time, like shock loading, you can say impact loading, cyclic loading, whereas fatigue types of loading is that loading which is subjected to some cyclic types or you can say fluctuating types of stresses, whereas static types of loading actually you can say it is not depends on time, that you can say, because it is a slowly applied load, this you should keep it in mind. Okay, and slowly and gradually applied load, this you should keep it in mind. So, here inertia would not play a role, that is also another important, whereas in dynamic case this inertia play a major role. So, first of all we should know what is the difference between static loading types of failure and failure due to fatigue. So, for static types of failure can illustrated by a simple tension test, that means by some universal tensile testing machine. Generally what happens, we can represent this static loading types of failure, whereas generally for fatigue failure generally the fatigue failure begins with a crack at some point. That point can be what? Region of discontinuity such as oil holes, keyways, thread region, as well as in case of welded joint, generally due to welding there can occur different types of welding related defects. So, from there also that crack can initiate. So, fatigue failure generally begin from those defect or those discontinuity. Why it is started from those reason? Because those discontinuity generally act as a stress concentration region. That is why from there generally, and due to this stress concentration region there rise the stresses tremendously due to the externally applied load, that you can say. Due to these things what happens, generally this fatigue failure begins from those discontinuity due to this stress concentration, where generally there can start a crack, that you should keep it in mind. So, second point you see, in case of static types of failure, here the loading or you can say load is gradually applied, this you should keep it in mind, and here generally there is sufficient time for elongation of fiber. What does your elongation of that structure? It generally to fail generally give you lot of time, that you can say. Then whereas in fatigue crack it is not generally visible till they reach to the surface. So, when it reaches in the surface, at that time generally the failure has already occurred, this you should keep it in mind. That is why fatigue failure is very difficult to design. Why? I will discuss in subsequent slides. Now, in case of ductile types of material, you see there is a considerable plastic flow prior to fracture, that you know. Whereas generally there that is why here I have written, in case of ductile material there is a considerable plastic flow prior to fracture. This result the fracture surface is silky fibrous types of structure. In case of static loading, whatever the failure is occur, in case of ductile material the fracture surface generally silky fibrous types of structure, this you should keep it in mind. Whereas there are two distinct area of fatigue failures are there, here I have written. The first area is the region indicating slow growth of crack. Once the crack growth is slowly due to this fatigue loading, then this fracture surface appearance is fine fibrous type, that I will show in next slide itself. Okay. And if second area is, if the region generally suddenly fracture, then that fracture surface generally looks like a coarse granular types of structure, this you should keep it in mind. That means slow growth of crack provide you a fine fibrous appearance, whereas a sudden fracture types of fatigue surface will looks like a coarse granular appearance. This I will show you in subsequent slide. Then in fourth point you see, in case of static types of loading, it is generally very easy to design, and it gives generally warning well in advance. That is why I have written here, it is easy to design, whereas fatigue failure generally is sudden and total, that means it occurs suddenly and it is generally at that times its failure is taken place. That is why it is difficult to design, because it is also this fatigue failure not only depends on this fluctuating types of loading, it is also depends on lot of other factors. What are those other factors, that also I will discuss in subsequent slide. Okay. So, here generally I am representing a fatigue fracture surface, how it look like. So, this is a symmetric diagram you can see, which is representing the fatigue fracture surface, how it look like. Generally you see it starts from some initial crack or discontinuity you can say, or you can say from stress concentration region, that is called initiation of the fatigue. Then what happens, this start propagating, that is called, that region you see from here to here, this region is called from initiation point to till fracture point is called fatigue crack propagation. That means, at that time first a crack start from some discontinuity, from there after that generally this crack start propagating. Okay. This propagation direction depends on type of loading, that how the structure is subjected to different types of loading. Depending upon that type of loading, generally this crack propagation will propagate in that direction. So, here generally I am showing the first crack initiation, this is one, second is this fatigue crack propagation, and finally generally catastrophic failure here you see is taken place. And how the surfaces look like, that experimental surface you can see. Here you see this region, generally here you see this first region is the initiation of the crack, then its propagate. So, in this surface region you can say this surface looks like a smooth surface. So, after that generally when it is fail, at that times you see this is generally rough types of surface or coarse types of surface, this you can say. Okay. Or you can say this is rough surface or granular types of surface. This surface appearance depends on what happens when it will be fine types of fracture surface and when will be some coarse types of fracture. Like you see this is a coarse fracture surface, whereas this is a very fine fracture surface. Generally this coarse fracture surface is occurs when the applied load is high, and here generally sudden failure is taken place. That I have already discussed in previous slide, difference between what happened static and fatigue failure. There I have shown there is two area, one is slowly growth of what is called crack or slowly propagation of crack, after that failure. There generally fine types of fracture surface you observe. This I have shown in this figure B, you see here fine structure you observe, whereas here generally load is high and here generally the rapid or sudden fracture is taken place. This fracture surface appearance you see is coarse in nature, that is why I have this, that is actually I am representing in figure A. This is experimentally observed surface. You can generally divide this fatigue surface into three different zone. What are those three different zone? First zone is you can say is crack initiation zone, or you can say origin of fatigue. After that you see there is a progression of this a crack. So, here generally crack start, after that generally you can say slow crack growth is taken place from here generally till this region. You can say this zone is called fatigue zone, FZ I am writing. Here generally slow crack growth is taken place. After that generally another zone is there, that is called fast fracture zone. This is generally called fracture zone. So, from here to here this is called, I am writing here, you can say instantaneous fracture zone. So, IZ zone you can write, that is called instantaneous zone, where generally first fracture is taken place, this zone, this you should keep it in mind. So, it is generally first fracture is taken place, this you should keep it in mind. Generally this crack propagation zone, you see this generally is subjected to, you see this surface is generally smooth types of surface, I have already told you, whereas this fracture surface is generally you can say rough type of surface, or you can say granular types of surface, or you can say granular types of surface. This you should keep it in mind. Now, in between you see there you observe some line. So, this line has a name, this line is called generally what? Bismarck line. I have already written here, you can see. So, during the slow crack growth there were a variation in the load that resulted in corresponding variation in the crack growth rate, which generally create this Bismarck. What is called? You see, it called Bismarck. This you should keep it in mind. So, this Bismarck generally start from crack, which initially its size is small and it is gradually increasing in nature, its size you can see. So, why this size is increasing in nature toward fracture surface? This is occur because due to this slow crack growth there was a variation of load, this you should keep it in mind. This variation of load is occur which resulted in corresponding variation of crack growth rate. So, here generally crack growth rate also varied, here the crack growth rate also varies, due to this thing generally this Bismarck is appearance. So, you got the idea. So, what is this 3 zone? That is, one is origin, another one is called you can say fatigue zone, where generally slow crack growth is taken place, and after that generally fast fracture is taken place, that is called instantaneous zone. This you should keep it in mind. Okay. Now, we will discuss about what are the different types of fluctuating types of stress and what is its characteristics. That is why here I have written characterizing fluctuating stresses. So, fluctuating stresses generally in a machinery often takes place in the form of sinusoidal types of pattern. You know, sinusoidal type of pattern means which is looks like sinusoidal curves. That means, if you start from 0, it goes to a maximum, then after that it goes to a minimum, again it is generally become 0, and generally it is varying from 0 to 360 degree. This is called sinusoidal pattern, you know this thing very well. It is not only subjected to this this fluctuating stress does not means always it should be sinusoidal types of loading. It can have some other pattern also. This pattern can be sometimes very irregular types of pattern also. 2 patterns I have here, you see I am showing. Here you see this loading can be initial point cannot be 0, and you see this loading can be not may not be very smooth also. What I am telling, understand? You see here there are lot of undulation of during loading also. Over a period this undulation is very high. This is called high ripple types of loading. This is called high ripple types of loading, you can see. And another case of loading, you see very irregular types of loading which is not sinusoidal types of pattern. So, you see these types of irregular loading also can called as fluctuating types of loading. What I am telling, understand? But here whatever the things we will discuss, mainly we will focus our study on the loading which is related to sinusoidal types of load. Okay. In rest of the lecture we will take only one types of loading, and after that we will discuss the details based on those types of loading. What I am telling, understand? Now, these fluctuating types of loading have a maximum load value F max and there is a minimum load value, that is I am representing in terms of F min. Here you can see. So, you see it has a maximum value, this is you can say F max, and this you can consider as F min. Okay. and this load is also varying with time. You see this horizontal axis represent the time and you see this vertical axis represent stress or you can say load. Now, depending upon this maximum and minimum load, generally you see there can be two important terms. What are those two important terms? Because this terminology will be used in subsequent design of or analysis of fatigue related problems. What I am telling understand or fatigue related structure. That is why this terminology you need to know. So, depending upon this maximum value of load and minimum value of load, there can be two important component. What are those two important component? One component is called a steady state component and another component is an alternating component. What is this steady state component? A steady state component is represented by Fm or you can say mean load, you can say this is called sometimes mean load F, or this has a very popular name, this is also called mid range steady component of force. You see here I have written mid range steady component of force. What is the definition of this mean load? Mean load definition is maximum load plus minimum load divided by 2, this you should keep it in mind. Whereas, this alternating component of load is the magnitude, it is also the magnitude of that load, it is also called Fa means amplitude of that load, amplitude of this load, okay. A represent amplitude. So, amplitude of that load can be represented as F max minus F min by 2. Why mod is given? Because this is the magnitude I am showing, okay. This you should keep it in mind. So, generally here you see M and here I have shown A. So, generally you see for fatigue types of loading, mean means maximum plus minimum by 2 and amplitude means you see maximum minus minimum by 2. Generally for in case of minus, for remembering purpose I am just telling, the minus its first order is M, whereas addition generally its first order is A. So, here generally in case of this fluctuating types of loading, in case of mean we generally used to do addition, and in case of amplitude we used to do subtraction. Opposite thing generally we used to do for remembering purpose. That means where mean is there, mean means the first word is minus first word is M. So, here minus sign should not be there, here should be plus sign, here you see, whereas in case of amplitude generally we know addition. So, opposite things you should to use, the opposite first word you should use, that means minus sign you can use. For remembering purpose I am just telling this thing, okay. So, now we will discuss some more detail in case of characterizing fluctuating stress. Generally this fluctuating stress can be categorized into 3 different categories. One is generally called sinusoidal types of, you see this is one is called sinusoidal types of fluctuating stress, this first category, where you see here maximum and minimum, there is a maximum and minimum value which you see this is generally minimum and this is generally 0 load line. You see this OA line, you can say OA line or horizontal axis represent 0 load line, 0 stress line, this you should keep it in mind. So, you see, so these types of sinusoidal types of loading, so this is generally first one is called fluctuating types of stress loading, you can see. So, fluctuating types of stress loading, here it has a minimum value and it has a maximum value. So, this maximum value I am representing from 0 line to this and minimum value I have represented here, you see from 0 line to minimum. So, then in this case this is the one value, this is another value, okay. It has maximum minimum value. So, other side also it can have this types of loading. Now, from here you observe that we have represent what is the mean stress. So, mean stress generally I have already represented mean stress sigma m is equal to sigma max, generally plus, in case of mean it is plus sigma mean divided by 2. So, it is generally going in case of sinusoidal types of loading mid range or middle of this, you see this is the mean value. So, this I have represented. So, this is the mean stress. How it is coming, you know these things very well. Now, in case of amplitude also I have shown here, you see this amplitude is this maximum minus. So, amplitude also here you can write as sigma amplitude is equal to, you can say sigma max minus sigma mean divided by 2. So, its amplitude will be generally, you see what is the amplitude? Amplitude will be, you can say half of this you can say it is generally going from minimum value to, you can say mid range or mean line, or you can say it is varying from maximum value to what it is called mid range line, this you can say. What is amplitude? So, amplitude also I have shown here. So, this you can easily calculate. Now, in case of fluctuating types of loading, one thing you should keep it in mind, here generally your mean value is not equal to 0, and here this is one important point you should keep it in mind. So, in this types of fluctuating types of loading, your mean stress value not equal to 0. So, this is one categories of fluctuating types of loading. Another categories of loading is called repeated stress loading. This is called, so first category is fluctuating, second category is called repeated stress, and this third category is called reverse types of loading. Reverse types of loading, this is the third category. So, in repeated loading you can observe that, you see it has a maximum value and this minimum value generally is 0. So, here sigma m mean equal to 0. So, here one thing you should keep it in mind, here there is a, you see you see there is a amplitude and you can say mean value, here amplitude is equal to here the mean value, this you should keep it in mind, okay. Because here generally your minimum, this minimum component if it will be 0. So, sigma m will be sigma max by 2, sigma amplitude also sigma max by 2. So, here this amplitude and mean value is same, this is called repeated types of loading. Now, generally here I have used another term sigma r also. Sigma r is generally range of stress, that means from the minimum stress to maximum stress, what is the stress range is there, that is represented as range of stress, here you can see. Whereas, in case of, you see repeated types of loading, in case of repeated types of loading, what you can observe, it has a maximum value and it has a minimum value sigma mean, and here this maximum stress magnitude and minimum stress magnitude is same, this you should keep it in mind. So, if this sigma max and sigma mean magnitude is same, but its maximum value is positive in nature and minimum value is compressive in nature, one is tensile in nature, another one is compressive in nature. That means, sometimes it is going up then down, up down, sometimes that. So, that types of loading is called generally repeated types of loading, you see. So, in case of repeated types of loading, what are the things you can observe? Here sigma mean value generally equal to 0. How it is coming? You see, Here generally sigma mean means sigma max plus sigma mean divided by 2. So, here let sigma max is sigma and sigma mean is minus sigma, that divided by 2. So, this will be 0. So, that is why here I have written in case of repeated types of loading sigma m equal to 0, whereas in fluctuating types of loading I have shown it is not equal to 0. These are the things you should keep it in mind. This is the characteristics of this fluctuating types of loading, and it has a amplitude, you see it has a amplitude, how it is the half of range of the stress you can say, but it has this mean line on mid range line generally has 0 stress value. This you should keep it in mind. So, another two terms you need to know, one is called stress ratio, another one is called amplitude ratio. So, what is a stress ratio? A stress ratio is generally represented in terms of R. It is the ratio of minimum stress of that fluctuating types of load or fluctuating types of stress. Minimum stress divided by maximum stress is called stress ratio R, and amplitude ratio is amplitude stress divided by mean stress. These are the very important point you need to know, because these are the things will be required once we discuss the advanced thing related to what is called this fatigue failure or fatigue failure related design. To find out the fatigue life of a structure, how experimental procedure or what are the experimental procedure generally we use. That is why here I have written experimental procedure for fatigue. Generally by this procedure what we used to do, we used to find that for a particular loading how much number of cycle a structural component can sustain. What I am telling, understand. So, depending upon this loads, the load value you can say this number of cycle varying. What I am telling, understand. So, this load versus number of cycle, or you can say fatigue failure cycle, generally is plotted in a curve, that is generally called stress versus number of cycle curve or SN curve. That curve generally how to find by using some experimental procedure, that related things I will discuss now. So, before going to discuss that experimental procedure, first of all here generally one of the very important parameters you can say or important properties of this fatigue analysis related thing, that is called endurance limit, that we need to know. What is endurance limit? Generally for a particular types of material, this endurance limit can be defined as the maximum value of completely reversing stress that a standard specimen can sustain for an unlimited number of cycle without fatigue failure. So, that maximum value of completely reversing types of stress is called what? Endurance limit. So, here generally the stress type is completely reversing types of stress. What I am telling, understand. So, this is your 0 stress line, and completely reversing types of stress, you know it has a maximum value which is tensile in nature, and it has a minimum value which is compressive in nature, and the magnitude of sigma max and sigma min, you can say magnitude which is mod value is same. What I am telling, understand.